All right, so today we're going to be combining Chapter 10, Lesson 10, and Lesson 11 together. Unfortunately, the book does it gives poor examples of how to teach this, so I'm going to be doing my own lesson, so you really won't be using the book for much more than looking at this right here. So we're dividing whole numbers by unit fractions. Remember, a unit fraction is like a 1 with a fraction underneath it, or excuse me, a number underneath it. So it could be 1 out of 12 pieces. That unit fraction is representing 1 out of the total number of pieces. So we're going to travel over here and do a little vocab review before we get into the meat of what we're doing today. So first of all, a fraction. A fraction represents a part of a whole. But I want to do a little language arts lesson here. Is it this kind of whole, W-H-O-L-E, or is it this kind, H-O-L-E? Well, hopefully you recognize that the H-O-L-E is like the hole in the ground. And I always remember that because hole rhymes with, hole looks like mole. The mole lives in the hole, whereas the mole doesn't live in this kind of hole. That particular kind of hole with this W is representing a part, it's representing the whole thing. Okay, so a fraction is part of a whole. So if I have 3 out of 9 pieces, I'm representing that there are 3 pieces out of a total of 9 pieces. All right, and to keep going with our terminology here, that numerator is the number on top. The denominator is the number on the bottom. So this is the parts of the whole. Okay? And a benchmark fraction, let's keep going. Benchmark fraction is representing fractions that we know. So if we have something like 5/9, we're trying to figure out what 5/9 is closer to. So we could say it's closer to 0. We could say it's closer to a quarter. It's closer to a half. Or maybe it's closer to 3/4 or even a whole. So these are benchmark fractions. They are easy numbers that we can look at and be like, oh, I know what 3/4 stands for. I know how much that is. Okay. And to continue, we're now looking at a whole number. A whole number is just the whole thing. And every whole number has an invisible 1 underneath it. That mixed fraction has a whole number with a numerator and a denominator. So that's a mixed fraction. You have a whole number plus the fraction. And an improper fraction has a bigger number on the top as a numerator and the smaller number on the bottom as its denominator. Now, equivalent fractions could look like this. 3/6 is equal to, let's make it really hard. It's equal to 20. Let's not make it too hard. 21 40 Now you might look at these and say, how in the world are those equivalent fractions? Well, you can tell because 3 times 7 is 21 and 6 times 7 is 42. Okay? Simplest form we know is just getting a number down to the smallest possible thing that nothing else can divide. It has nothing else in common to divide by except for 1. So 5 can only be divided by 1, and it's number 5. 9 can only be divided by 9 and 1. So the 1 is common, so it's in its simplest form. All right, now we're really going to get into what we are supposed to be learning today. So today we are looking at keep me, change me, flip me. And again, you're not going to be using the book for your work today. You're going to be using quizzes for this. So when you get onto quizzes, you're going to go over these vocab terms that we just had up here in one of your quizzes, And you're also going to be going over these kinds of problems down here. Okay, so keep me, change me, flip me is what I always say, so I remember how to do division of a whole number and a fraction. All right, so let's check this out. If I am following this policy of keep me, change me, flip me, then I'm going to keep this 4 the same. I'm going to take that division symbol and change it to the opposite of division, which is multiplication. And I'm going to flip this number. So if it's 1 over 3, I have to flip it. So it's now 3 over 1. All right, and we're looking for what this equals. So we know that any whole number really has an invisible 1 underneath it. So I can now do 4 times 3 is 12. And I can say that 1 times 1 is 1. So that's an improper fraction. Let's go ahead and simplify that. So 12 divided by 1 is 12. Okay, and again, let's go back up here. The policy we're going to follow is keep me. So keep me, change me, flip me. So let's do it again. Let's click that again. So here we go. We are keep me, change me, flip me. So we'll keep the 3, change the division into multiplication, and flip me, we're going to turn 1/5 into 5 over 1. All right, and again, we know that all whole numbers have a 1 under them that we just don't see. So now we have 3 times 5 is 15. And 1 times 1 equals 1. Now, I know a lot of kids, and actually adults, I do it too, we want to know why we would do this and when we would ever do this. So the question would be, okay, when would I use this? I have 6 candy bars. So I have 6 candy bars, and I want to break each of those 6 candy bars into quarters, because you could do that pretty easy. Like think of a Hershey's bar, right? So you want to break them all into quarters. Maybe you're going to use them for s'mores. So you want to know, hey, how many people are going to get little pieces of candy bars once I separate these 6 into quarters? And so let's check it out. Let's see how much of the s'mores you guys are going to get. So we're going to keep the 6. We're going to change the division. And we're going to flip 1/4 into 4 over 1. Okay, and again, we just multiply across. So we have 6/4. 6 times 4 is 24. And those ones would make 1. So there's going to be 24 available pieces. So out of that original 6 Hershey's bars, we're going to have enough for 24 people to make a s'mores. All right, let's do this last one. And then I want to show you something else, because there is a little twist to this. So 5, I'm going to go ahead and put my 1 under there right now. So keep me is going to be 5 over 1, because I'm going to keep him the same. Change me goes to a multiplication, and flip me is going to go to 4 over 1. Go ahead and solve it, and we have an answer of 5 times 4 is 20. All right, now this was kind of a simple way of doing things today, because this denominator was always 1 underneath here, because we had a whole number there. But I'm going to throw in a little bit of extra for those of you who are ready here. And that's okay if you're not ready. But let's say I had 7 over 9 divided by 1/4. Now this is, actually I'm going to say 1/2. So 7 over 9 divided by 1/2. Well, if I stay with the same thing, and I am going to, give myself some more room to work. If I'm going to do 7/9, I'm going to keep that, right? Keep me. And then we have the change me, so that goes to multiplication. And then we have the flip me, 1/2 now becomes 2/1. So now I have a totally different problem than what I was doing up here when I only had a whole number. So I still multiply across. So 7 times 2 is 14. And 9 times 1 is 9. So it's not too much different, but you don't just get to stop right there. Now you need to figure out, okay, how many times will 9 go into 14? Well, it'll go once, and you'll have a remainder of 5 out of 9 pieces. Again, you're not going to do that today, but I just want you guys to recognize that once you have this extra piece under here, once you have a fraction, it's going to be very different. But today, you're going to be working on this. He has a key. He's lying.